trying to write it down, trying to put it in, and you're able to keep multiplying.
Well, there is multiplication there. What did you try to type in?
It
2x minus 6? Well, hold on. You know that 2x is the same thing as 2 times x, right?
Right.
So that's correct.
I know, but
that's the same thing. It's automatically doing that because it's supposed to. Yeah, you're getting frustrated for no reason. So make your answer. Yes, ma'am. What'd you put in? Yeah, you can't type that in there. What is 2x minus 5x? Right. But what do you, just maybe guess, what do you think 2x minus 5x would be? Maybe negative what? So negative 3x minus 21. But even if that wasn't letting you do that, right? Even if it wasn't letting you do that, couldn't you have typed this and then that? It's at least have something in the calculator? Dude, we're starting now. Yeah. All right. Stopping poll. Only 22 of us got our answers in, but you know. So let's look at it. Negative 3x plus 9, negative 3x minus 11. It looks like a lot of us are getting more similar answers. So you know what that tells me?
We're growing.
We're learning. We're getting better at it, right? We don't have to be perfect at it, but we are learning and growing, and that's the focus. So most of us would not have gotten this answer correct early on, and we're getting better. But let's look at this all together, okay? Can someone give me a first step that we can use here?
Distributive property.
Can we distribute here? Specifically, what are we distributing? What like operation? Multiplication. Specifically here, we're multiplying by 2. So 2 times x, 2 times negative 3 gives me 2x minus 6, okay? Do we need to distribute here as well?
yes.
Yes. Minus 5x minus 15. And I even see that one student has exactly that, right? So is that an equivalent form of what we started with? Yes, and that's a good distribution. But I did ask you to simplify, go all the way. So what else do we need to do at this point? Taylor? So which one? Ah, the commutative property is beautiful. What are we going to commute, right? Switch order of?
The curve.
So 2x, now minus 5x, minus 6, minus 15. You see all these people who got plus 9? I don't know for sure, but my guess is that they tried to add 15, because negative 6 plus 15 is 9, right? But notice, we're not adding. We don't have an equation that we can add 15 to both sides on. This is why the commutative property is so good, because now I can just put my like terms together. What's negative 6 minus 15? And then 2x minus 5x? Negative 3x. Minus 21 is where we want it to end. Okay, so we're getting closer, but only one of us got it perfect, but we're a lot of us close. Yes? Oh, thank you. Up here is supposed to be positive 15. My bad. That's what I get for rushing. I lied to all of you. So that should be... Nope, we're much better than I thought. That's exciting. Sorry, so be careful if you... I was remembering what I saw someone else do and I just didn't think. Negative 5 times negative 3 is a positive 15. Right, so be careful about that. I think, Maddie, did you have minus 15 there?
Nope.
I have minus 15.
Written down? Or did you have plus 15? You have minus? Yeah. That's what I was thinking about. But notice it's negative 5 times negative 3, so a positive 15. Does that make sense? So it is supposed to be negative 3x plus 9. Yeah. Sorry, that was my bad because just thinking about other things I've seen. So we were very, very close there, but last detail that I want to point out. Two last details. First off, 2x minus 5x. Why is that negative 3x?
Because the 2x is positive and then the negative 5x is negative. So when you add a positive to a negative, it's going to be a negative.
Yeah, but we have x's there. How does 2x minus 5x become negative 3x?
So like terms.
And? There's more to it than just that.
Because you're subtracting 5x's from 2x's.
So remember what we're really talking about here, and Joey, this is an important thing to remember. This is multiplication, and multiplication is repeated addition. So what I really have is x plus x, and then minus how many x's?
5.
Right? And so this x minus x is 0. This x minus x is 0. And so I'm left with
Negative 3x.
negative 3x, 3 negative x's. That's where that's really coming from. Did y'all know there was an easier way to do this problem though?
Yes.
Yes? What do you think it is, Jamie?
I just added.
What do you mean you just added? I'm saying I could have done, what I'm referring to is I could have done it in 2 steps from here. Instead of all this. Does anybody see it now?
No.
No?
It's because the x and negative 3 are the same there.
So what is this really saying? That I'm repeatedly adding x minus 3 twice, and then what am I doing? Subtracting x minus 3 5 times. So if I have 2x minus 3s and I take away 5 x minus 3s, how many x minus 3s am I left with? Right? It's the same idea that 2x minus 5x is negative 3x. Well, it's because I have 2 x's and I'm taking away 5 of them. I have 2 x minus 3s and I'm taking away 5 of them. Now I can distribute. Same answer. 2 steps. We just want to notice that and look for that idea of, do we have, y'all keep talking about like terms, but I want you to see that in a way, these are like terms. The x minus 3s are in common. Man, we drop things all over the place in my classroom. All right. So, let's move forward. It's just giving us more practice and looks at simplifying. What I will say is, I have one more question I want you to think about. So what numbers are included in a 5-number summary?
We did. We did decide on
And so please note, I'm not asking you to give me actual numbers, I'm just asking what are the numbers included in a 5-number summary?
It's not showing for me.
Hit the home button for me,
What
please.
are you referring to? The sheet we did yesterday, or just like?
Click pull right there. Yeah, I mean, it might have been on the sheet we did yesterday. Look at your notes, see if it's there. There's a 5-number summary for data set. I'm looking for it right now for you. I know, I'm looking for it.
Okay, now
Where are they?
minimum, Q1, medium, third, and maximum.
Was anyone else besides Thomas and Coda not here yesterday?
Oh, that's right, we got the little.
Also, did anybody else not get this rubric yet? Jamie, I think you haven't yet, right? That's the scoring rubric for understanding checks. Say again? Huh? Did I give this back to you? That means I didn't rate any of those zeros in the grade book right now. All right, we got 23, 26, topping the poll. Let's look at it. All right. Should have been a little bit quicker on it. All right, so I see a couple of different responses, but what are the most common responses? Min. What does min refer to? The minimum value. Q1 meaning the first quartile. Median.
Quartile 3.
Third quartile.
And
And maximum. That's the 5-number summary that we use for what type of graph? Box and whisker plots or box plots, right? So we're going to look more at it a little bit today. But yes, the 5-number summary, those are the things that we need to recognize. Alright, so let's keep that in mind. Looks like we're getting there. Hopefully that was a good reminder for those who needed that reminder. So here's what we're looking at today. Agenda. So we're looking at measures of central tendency, the IQR, which we'll talk about in a second, outliers, and standard deviation. So here are those objectives, right? I need you to pay attention to objectives because they are telling you what to learn. We need to be able to calculate and interpret measures of center. I think that we are getting more comfortable with mean and median. We're going to continue practicing with that, We also are going to get into today when to use which measure of center, right? Mean and median are measures of center of data. And so we need to know when to use each one because a median is sometimes better than a mean. And then we're going to learn about the measures of spread that go with each and learn about outliers. I believe we already did this one yesterday. We kind of talked about it and we discussed the idea that here with this one, didn't we say that we thought the mean and median would be about the same? Yes? Yep. Whereas here, I think we said that the median would be here, and that the mean would be a little bit further to the left. Right? And then here we said this was our median, because literally it's a box plot, but our mean would be pulled further to the right. And so we kind of discussed this idea, and we're starting to think about it. The mean is pulled in which direction?
Towards the extreme values.
To the extreme values. So it's not always to the right. Notice the mean was pulled to the left here. So it's pulled in the direction of the longer, what's this thing called? Starts with a T. Tail. I think we already talked about it. What is the shape when you have a longer tail like this?
Skewed left or skewed right?
So which one is this? Skewed left or skewed right?
Skewed left.
Skewed left. The skewness is in the direction of the tail. So this one would be skewed right. And the skewness pulls the mean in its direction. Okay? And so that's what we want to recognize there. Alright, we talked about this the other day. We know how to calculate mean. We talked about these symbols. But again, don't let those symbols freak you out. How do I read that symbol?
Average. Yeah.
It is the average, it is the mean, but literally you would say X bar. Right? It has an X with a bar over it. So called X bar. It means the mean, okay? And how do we calculate the mean?
Adding and dividing.
That weird looking E, what's that weird looking Greek E? Sigma. But what does that sigma mean to do? It's the sum. Whenever you see sigma, that just means sum. So we're summing all the X values and dividing by what? N, which is the number of values. That's it. So it's exactly what you've done in the past. This is just the actual and proper way to write it. Ethan, Jaden, y'all focus? Wesley, you're looking at that board? Okay. Guys, make sure you're focused. I cannot teach you if you're not engaging in the conversations. So at this point, I think we got through all that yesterday. Did we did the 5-number summary here, I believe, and we did the box plot, correct? Yes. That's where we ended. What was the minimum? 2. First quartile? 5. median,
9,
9, third quartile,
12,
and maximum.
32.
Okay, so min, Q1, median, Q3, and max. By the way, because someone in this class brought it up, does anyone remember another term that we can use for the median?
Middle.
It is the middle, but
Q2.
it could also be Q2, right? Q2 or the median, it could be either of those terms. All right, and then we have not done the mean yet. We just did the box plot. So 5. And one thing I do want to point out, what I often do is I do my minimum. I then do that first quartile, but then I just draw the entire box, right? So I go all the way to my third quartile of 12, and then I would mark my median now at 9, and then a max.
Oh yeah, I know it broke. Sound like it broke.
Yeah, guys, we gotta keep those calculators on the desk. Like, it ain't that hard. It's right there. Jaden, on your right. Don't use your feet to kick it across the floor. Get up out of your desk and get it. Or thank you, Winter, for helping him out. Golly. So, it's in here. All right, 2 quick things I want to point out, right? Again, please note, we need to make sure that we draw these whiskers to the middle of the box. That's the proper way to draw a box plot. Another thing I want to point out is, you may not have been doing this, but we should. Notice how there's a title for the graph, and there are units for those numbers as well. You should always title your graph, because nothing that you do for me, especially when it comes to data analysis, will just be numbers. It will represent something in the real world, right? So we're looking at the average number of hours spent in the gym each week, and then we have our number of hours, okay? Calculate the mean of the data. Actually, I want to give you all a chance to practice doing this. One thing that I'm always going to do when it comes to mean is I'm going to write out my formula first to remind me. The mean is equal to the sum of all the values divided by the number of values. And I would write it out before I put in my calculator. So, don't forget, every time you have a little mark, you have that number show up. So what's the first value that we have?
Mr. Penny,
Yes.
can you explain the Greek E and the X over the end again?
That Greek E, that sigma, just means to sum your values. By the way, it's also on the previous sheet. They break it down very heavily on the previous page.
What's
in your
the
notes.
N?
Huh?
What's the N?
Look on the previous page in your notes, just so you already see it. It's there. You see where they break down each piece of it? So I'll come and help you in a second, but I want to let students work on this. So what's the first value that we're going to be summing together?
2.
2. How many 2's do we have?
1.
Just 1. What's the next value?
5.
Okay, but how many times am I going to put 5 on here?
3.
Keep it going. Find the average of your data set. Find the mean of that data set. Yes, Maddie? So notice how there's 3 dots. So that means that we have 5 3 times. Okay? So let's actively collaborate, help each other grow and learn, and get better at this whole mean thing.
Okay. So 6 would be 1.
What?
Now we just gotta add it.
First off, you got a group. Have you talked to your group at all yet? Okay, so talk to your group first. I know. Talk to your group first. But talk to your group. I'm not asking you questions. You talk to your group first. I'm going to collaborate.
What we do now is average. So what we do is we count all the dots there. Except
5 to the third means 5 times 5 times
5 where the 3 dots but 5 3 times.
You could do 5
We're
times
gonna
3.
add all
I would just
together.
practice doing 5 plus 5 plus 5. It's just to make it simpler. Andrew, I need you to actually work on it.
Because that's what we're gonna do.
Well, I mean, that means to sum all the values, doesn't it? Have you done every value?
Did you not put the stuff up there? I have
No, see how it dot there to keep it going? Okay, let's, regardless, let's keep helping each other work and get better, okay?
He said that.
Went to 30.
Right.
And that's what
What's up?
I did it already.
told me that it was wrong yesterday. But
Yeah. So you don't need to, but so you can just start typing, right? So parentheses, do your 2 plus. So you can just start adding them, right? Now, if you once you clear it, you can, but you don't need to. The way to do that is you go to actions, and you clear the history. Why wouldn't you use 32? Is 32 a value? Pretty sure, so notice, I just put plus 5, plus 5, plus 5, but you should keep it going. What's the next value after 5? 6. What's after 6? Look at your dot plot. We're not, oh, I see what you're doing. We're not doing just the 5-number summary. We're doing the 2. We're doing the 3 5s. We're doing that 6, that 7, that 9, that 10. Right? You're averaging all the values. Does that make sense now? One thing I would do, by the way, is I would check to make sure I have all the data values. So like you have 1, 2, 3, 4. Is that 5? No. Is there a dot right there? Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13. You should have 13 numbers. Okay, really quickly, you can't add it here, but you see how it's highlighted? Hit enter. Now you can add it. So add another 12 to it.
That's one of the
Where's the previous page in your notes? Well, this, oh, that's right.
Why y'all teach her right?
What does it say? So however many there are, right? 1, 2, 3, 4, 5 numbers, so divided by 5. And how's it going?
Okay,
So you're trying, so your struggle right now, so that's your pencil. So make sure that you put the line all the way across and you're dividing by 12. Is it 12 or 13?
13.
Yeah, 13, right? So it's divided by 13.
You saw me on the people.
So make sure you fix this. So there's 2 different ways to get this. Hit control and then enter.
My first attempt, I added all the numbers and 32. I
Look at your numbers again. Did you divide everything by n? And also, how many data points are there?
I
You might want to check that again.
added all the numbers together and moved it and then put
How'd you get?
131 over 32.
Thank you. Thank you. Thank you. I need y'all's attention on this because this is not, I've seen this show up a couple times now. When we say the sum of x, the values, does it just say some of the values? Like a few of the values, or does that mean all of them? All of them. And not just the 5-number summary. It's every single value up here. So that what's the next value after 5? 6.
7.
And then there's a 7. And what's after 7? 9. We don't have an 8, right? No x there. Then after 9, 10. It's every single value, not just the 5-number summary. Okay? I do want to show you one thing really quickly. If you mess up on the calculator, I need you to pay attention to this. Because I saw a student earlier, and I've seen this a couple times actually, at a calculator, so I've seen like, alright, what was it, 2 plus 5, plus 5, plus 5, plus 6, plus 9, plus 10. Was there a 7? Thank you. Okay, so actually this will make my point. So I hit enter. Oh dang it, I forgot the number 7, right? if I hit the up arrow, do you see how it highlighted that entire 42? Do you see that, Kyla? Because you're looking at me, not up there. See how it's highlighted that entire numerical expression? If I now hit enter, it brings the whole thing down so that I can now add 7 and I can add that number in. So if you realize you made a mistake, be aware of that. Hey, Maddie and Aiden, hold on, pay attention, okay? Here's the next thing I need to point out. I now want to divide that for an average by however many numbers there are. So right now I have what, 7? Or is that 8? That's 8 numbers, right? So please, I know that this isn't all of them, but let's say I now divide by 8. Do you see how it just gives me a fraction? Y'all, I need y'all engaged in the conversation. Maddie, Trent, I need you to focus on the whole class conversation right now so that you know how to do this in the future. I don't want a fraction, I want a decimal. So I'm going to go up and hit enter. Can someone tell me one way to make this a decimal? So if I put a decimal in any of the numbers and hit enter, it makes it. Lillian, do you know the other way?
Press control and then enter.
Right. If you look above enter, it's got the wavy equals to, that means approximately equal to. You hit control and then enter, and it automatically makes it a decimal as well. So multiple ways to make decimals. Make sure when you get the average, you get a decimal value. Let's finish this up in the next couple minutes.
We got 4.093. You divide how many there is at the bottom, 2, 3, 2, you divide it all the way through 32. So 131 divided by 32.
You said divided by what?
32. Yeah, whatever is at the end, the dot plus approximates the same. Divide.
What did I do? 13. If I can, oh, put together.
It did this.
It doesn't matter. Yeah, it doesn't matter where you put the decimal as long as you just put it in there. And
So that's my answer.
you got 4.0937. Why'd you divide by 32? Because 32.
What does n represent?
Maximum is the maximum.
Flip it back over. This page back over. What does it say n is?
Number of data values.
That's not the maximum. N is the number of data values.
5 or something.
So, well, if you look right here for this example, it was 5 because there were 5 numbers. But look here, how many numbers are there?
13.
There's 13 numbers. So what are you supposed to divide by?
13.
13.
31 divided by
Right.
It's okay.
What's that? What number? So there's one value with the number 14. Okay.
I got 7.
See how there's one X right here? So that means there's one value with what number? 13. Right here though, see how there's 1, 2, 3 X's with 12? So how many
Once you add up
values have the
I
number
got
12?
10.0769.
So that's why you do,
Add all the
so you
numbers
do 2
in,
plus
put
5
it
plus
in
5 plus 5. But you see how there's a 6 right here? So you need to add that 6. You need to add that 1 7, that 1 9, that 1 10, those 3 12s, that 14, and that 32. Hold on, Maddie, look at me. I just spent 5 minutes. I spent 2 whole minutes telling the whole class how to get the decimal version of that. You were busy having a side conversation. So show me. How do you do it?
Sit down.
So why are you freaking out?
Ooh.
You're getting your own head for no reason.
Oh,
Thank you. Thank you. Okay, so let's bring it together. Let's talk about it. From what I can tell, quite a few of us have already gotten this idea. Do I need to address any concerns or questions that you have at this point?
I just learned it.
Huh?
I just learned it.
Just learn how to do average or mean?
Yes, like.
At least we know how to do it a little bit, right? You understand it now?
Yes.
Okay. So, now what does it ask us to do? Mark X bar above the point on the number line. So that 10.077 would be roughly here, just above that 10. Did y'all mark your X bar? Good.
No.
About.
You must be outside your mind. You better not have anything besides math out in my class ever again. No, Okay. So there's the X bar. And so there's this question of what do you notice about how the data are clustered? And that's an odd question. So when we talk about how things are clustered, what we're talking about is how are they grouped together? Okay? So when I look up here, how are they grouped together? Like the data we should notice is within this box plot. How should we notice that they're clustered? Okay, so when you say less hours, are you talking about like it's clustered together on the lower end? Can anyone tell me what percent of my data has to be between 2 and 12 hours? How much? I hear 45%? It's not? Say again. Say it louder. Okay, 25 between the very smallest and the value right here? I would say 25 is a part of it, but I wouldn't say 25. I'd say 50.
75.
75. Remember, 25% is in this one tail right here. 25% is between the first quartile and the median. And 25% is between the median and the third quartile. What percent is that?
75.
75% of my data is grouped together between 2 and 12 hours. Right? So how is it clustered together? And then beyond that, another important detail is, you see on this box right here? 50% of the data is between what values? 5 and 12. Okay? So we would want to notice, right? 75% of data between 2 and 12. 50% of data between 5 and 12. And really we need context with it, but I'm trying to move forward a little bit. So we should note that. Intro. It's not funny, man.
Sorry.
So, let me ask you an important question. Does that 32 seem a little weird to y'all?
It's an outlier.
It might seem like an outlier. 50% of my data is between 5 and 12. 32 is pretty darn far out there, right? Now here's the thing, Joey, and hold on to the idea of an outlier, but we have to learn how to prove that it's an outlier. There's a mathematical way to say if yes it is an outlier or no it is not. And that's why there's this question of clustered. There's a lot of our data that's clustered really close together. 50% of it is just between that 5 and that 12. So 32 seems really far away. And so that's what we're about to learn about is how to identify it. Now I do want to point this out before we move on. Did y'all notice that the mean is a little bit to the right of the median? Why is that? Because it's skewed to the right. Remember, the mean is pulled in the direction of the skewness. It's not super far to the right, but it is pulled in that direction. Okay, so let's find out how to determine if that's an outlier or not. I think that's the next part. Oh, it does talk about it here. This is the last thing before we talk about how to determine outliers or not. So here's the thing that we want to recognize. If, right, or so the overall shape of a graph is called the data distribution. We've already talked about skewed left, skewed right, and symmetric. So notice, I don't particularly love these graphs. I might draw new ones above them. This might be on the next page, by the way. It's on page M4-21. Okay. I would probably redraw these in this way, showing tails like that. Notice how it has a longer tail to the right. If it's symmetrical, the tails are about the same. And then there it is, skewed left, okay? Notice the same thing still holds, right? If it's symmetric, the mean and the median are going to be the same. If it's skewed right, the median might be here, and the median is going to be pulled to the right. And if it's skewed left, the median will be close to that center, and the mean pulled to the left. And so what we want to notice is here, all of this information, it appears when there is skewness, which measure of center is better? The median. When there is skewness, the median is the better measure of center because the mean is pulled in the direction of that skewness. When there are outliers, the median is a better measure of center because the mean is pulled in the direction of the outlier. And so we need to be aware of that. So when are we going to use the mean? When it is,
In the middle.
what's the term?
Symmetrical.
Symmetrical. We want to recognize that when the data is skewed, we prefer the median. And when the data is symmetrical, we use the mean. So which measure of central tendency are we going to use for the Geom data? Jaden, do you know which measure of central tendency we'll use for the Geom data? Are you remotely engaging your brain in this conversation that we're having? Or taking notes at all? It's really hard to learn and grow if you're doing nothing, my man. I don't expect you to be an expert, ladies and gentlemen. I just expect you to be a part of the conversation. You'll learn and grow as a result. Say again. I would put it under number 2. There should be plenty of space there. Okay? The space on the edges is for notes if you need them. Okay? But my question right now is then, which measure of central tendency would you choose to represent the data set when it comes to the Geom? Based on this information, which measure of central tendency should we use? Median? Why the median? Yeah, were the Geom hours skewed? Yeah, it was skewed right, so we're going to use the median. So use the median because the data with Geom hours was skewed right. Or I guess the data were skewed right. what are your questions at this point? You're bored, you good? Alright, so here is the idea about, or this is what's going to allow us to talk about an outlier. Can I erase this part about using median? Yes? Okay. So first off, I want you to note this, remember, okay? We talked about an outlier as a data value that is significantly greater or less than other data values in a data set. But we need to figure out how to mathematically prove whether it's significantly far away. Hey, Janai, you back? Hey, way back there? Oh, okay. I was afraid you were asleep on me. Okay, so we've already mentioned it. What are the four parts of a data distribution that we need to analyze? There's four things we need to analyze when it comes to a distribution. Center, unusual,
shape and spread.
Aspect, shape, and spread, okay? So which one have we not talked very much about? Okay, we haven't talked about unusual aspects, but we also haven't talked a whole lot about spread, have we? So we talked about range. I think that's the only type of spread we've talked about, though. And there are several other. Yes, Jamie?
What does CUS stand for again?
That's the C is center, the U is unusual aspects, the S is shape, and then the last S is spread. So center, unusual aspects, shape, and spread. Okay, so the first important measure of spread that we're going to study is the IQR, the interquartile range. And let's break that down, because they tell us exactly how to calculate it right here. It's super easy. The IQR, or interquartile range, is simply Q3 minus Q1. They define that, okay? But I don't want you to just know that. I want you to understand why. And it is plainly seen if you look at the language. Interquartile range. Now, we talked about this before. How do we calculate range?
A greater distance or speed.
No, not quite. The range of a data set.
The difference in the number, the minimum and the maximum.
Yeah, it's the difference in the minimum and maximum, right? So to find range, not interquartile range, but range, we did max minus min, right? That's how we calculated range in general. So what do we mean by inter and quartile? Very close, I'm trying to remember. I think intra means within, inter means between. Between the quartiles. This prefix inter means between. So we're looking at the range between the quartiles. Well, if I'm looking at a box plot, just in general, you don't have to sketch this out, but if I look between Q3 and Q1, isn't Q3 the maximum for the quartiles? Yes, and what's the minimum for the quartiles? Q1. So what do? We take the maximum Q3, we subtract the minimum Q1, because it's interquartile range. It's not the full range, it's just the interquartile range. So it's the range between the quartiles. So interquartile range, it is the range between the quartiles. And so we talked about two different types of center so far. What are the two main types we've talked in this lesson? Mean and median. We are finding out here what measure of spread goes with the median. Read the notes. What does it say? In a quartile range, right? If the median is the better measure of center, then use the IQR. So if you have a median, you're going to use the IQR for the spread. That should make sense, because what's in between the quartiles? The median. So if you have a median, you're going to use the IQR. The next measure of spread that we'll look at in the next lesson is standard deviation. So we'll get to that later, but I want you to note, right, the IQR goes with the median. When we study standard deviation, that's going to go with the mean. All right? But I want you to now look at number 3, work with your group. It shouldn't take us too long. Calculate the IQR of the data in question 1. That's the data about the gym, right? So let's find that IQR for the gym data. It's on the previous page or 2.
How do we find that?
Wait, where's it? This page? It was after that. This was the sheet you were trying to find. Remember how you were like, I couldn't find M4-15? That's it.
It doesn't say M4-15.
So M4-14, backside is 15. This goes with that. Notice M4-19, M4-20, and 21.
So you just do this tonight?
Did you find your IQR? Okay.
I'm stupid.
Huh? Say it one more time. Q3, Q3 minus Q1. Thank you. Thank you. Okay, so what's my IQR? 7. How do we calculate that? Q3 minus Q1, which is 12, minus 5, which is 7. You need that IQR to figure out if you have outliers. That IQR defines outliers, or will be used to define outliers. I'm about to explain it. I said you need it to figure out if you have outliers. And here is how. They give you a procedure right here where they say that if you take Q1 and you take away 1.5 times the IQR and a value is less than that, then it's an outlier. I don't like that language. Yes, ma'am?
So if the value is less than 7, then it's an outlier.
And see that, so it gets a little confusing. So hold on. We're going to use that 7 to figure out if we have outliers, right? The 7 is not the outlier, or the marker for an outlier, okay? So notice what it's saying right here is if I take Q1, what is Q1? 5, okay? If I take 5 and I subtract 1.5 times, what was the IQR? 7, I thought, right? IQR was 7. What is 5 minus 1.5 times the IQR? I don't know. Got calculators though. Woo!
How did you get 1.5?
It's told to us right here.
Negative 5.5.
Negative 5.5. Okay. Do we have any numbers to the left of negative 5.5 in our data set? Do we? No? Actually, hold on a second. I think this is on the very next page already where it's at. Yeah, it is. Okay. So if you go to here, the very next page, I was jumping ahead a little bit. There's a lot of work here, all right? But this is the actual work to go with that problem. And so notice they have the IQR of 7. They have what we call a lower fence. If a data value is lower than the lower fence, then it is an outlier. Okay? So if a data, technically this datum, You didn't know that datum is singular, data is plural. But if a datum value is less than lower fence, then it's an outlier. Okay? So that's where they get this negative 5.5. They mark that negative 5.5. Are there any data points to the left of negative 5.5 when it came to the gym hours? No.
Where do you get
I didn't have negative hours.
That's exactly right. It's not possible. There were no data values less than that. Remember, this is just the lower fence. If there was a data value lower than the lower fence, then it's an outlier. We don't have any because it's not even possible. Okay? But now we also need, if there's a lower fence, we also need an, okay, lower and upper. Yes, Jamie?
So if 32 isn't identified as an outlier, what is it identified as?
No. We said we don't have a lower outlier. We haven't checked any upper outliers yet.
Oh.
So remember, I just said if a data value is less than the lower fence, I meant to say it's a lower outlier. We haven't checked the upper side yet. So now we need an upper fence. Okay, but an upper fence isn't going to be based on Q1, it's going to be based on Q3, the upper side, right? So we're going to take Q3 and we're going to go above it. So do we add or subtract? So we would add 1.5 times the IQR. And Q3 was 12, is that right? Plus 1.5 times the IQR of 7. What do we get?
Oh, it's 22.5.
22.5? Is that what you're saying, Lillian? Okay, so 22.5. Do we have a value above that 22.5?
Yeah.
Yes. So that 32 is known as an upper outlier. So Jamie, it is an outlier, it's just an upper outlier. Notice it's beyond the upper fence. Okay? So if a datum value is above the upper fence, it is an outlier. Okay? Yes, Maddie?
So we have to do like both of these to find the outliers?
Because you have to check to see if we have any lower outliers and to see if we have any upper outliers. You have to check them both.
So we're going to use this often?
If you're checking for outliers, you want to check them both. And so what I do want you to note is the upper fence, right, is based on Q3, and we go above, so we're adding. The lower fence is based on, so lower fence, that's based on Q1 on the lower side, and we're going below, so we're subtracting. But notice it's still 1.5 times the IQR each time. Okay? So really quickly, remember back here when we created our box plot, and so we had this here, Q1, Q3 was 9 the median, and then we went all the way out here, right? But there's only one data value all the way out there, and we just found out that that 32 is a what? So we're not actually going to put our whiskers all the way out to that 32. We're going to stop at the last value that wasn't an outlier. What was the last value that was not an outlier?
14.
14. So we actually stop our whiskers at 14, and then you put a dot at the outliers. If you look at the page that you see in the book, is that what they did? They stopped the whisker at the last value that is not an outlier, and then they put a dot at the outlier, right? So pay attention to this. They have it worked out. They have it explained. Those are notes. Maddie.
So whatever last value has like X above it, then that's the last outlier.
Say it one more time.
So whatever value has an X above it, is that's the last outlier?
Well, you talking about like right here?
No, like when you said 14 was the last outlier.
No. 14 is the last value before we get to outliers. Because remember, what was the upper fence? 22.5. 14 is the last data value that is inside the 22.5. So we stop the whiskers at that 14, and then we put a point at the outlier. Okay? Now I need to warn you, you will need to get some practice with this. You cannot just say, oh, I get it, that's it, right? There's the conceptual side, understanding how and why it works, but you need the procedure to actually put it into play a few times. No. We already did that. I don't know why I have that slide in there twice. And so we're going to move to activity 2.2 at this point to use the IQR to identify outliers. Okay? Now we're going to play around with some other things with just box plots in general. We're going to start looking at how to compare these. Ezra, it is page M4-24. So you should be looking at M4-24. And so we are going to use these box plots and this data to determine if we have outliers or not. But first I want you to start on number 1. Which year do you think was better in terms of points scored? Talk about this with your small group. You don't have to have the correct answer. We're just going to discuss it. Let's talk about it. Let's figure out an answer with this for in the next 2 to 3 minutes. Okay? So come up with an argument. Yes,
Probably
he's about to go. You need to grab a seat.
Some people.
Grab a seat, do some work.
Well, no, we're just saying which year.
They actually all scored even.
Maybe right.
What's the whole group thinking? No, guys, like come up with a. There's no right answer. Come up with an idea.
There's another bigger.
I have a headache from my students not doing the work I asked them to do, but you know.
Yeah, I'll probably agree with you.
That's because you're not used to it.
Some,
But your brain is just like a muscle. It gets stronger when you work it out more. So let's start using
3
it.
times 24, 2 times 17.
Well, that unfortunately your mom feels that way about you, but I don't. I know you're capable of great things. Let's get to work.
First,
What do you think?
1 is about 2.
Did they always score 45?
All right.
Okay. I'm not saying you're wrong necessarily, but as a counterpoint, what's the lowest value for 2017 in points scored? 0. So what are y'all thinking? 20 what? 2016, why? Well, and one thing I will point out is, don't just look at the table, look at the graph that's given. Does that graph support your ideas? How so? You don't have to know how to say it, just try to say something. Get involved in the conversation, put your brain in gear.
Almost every round besides they have
Thank you. Thank you. Thank you. Okay. So again, we don't have to have a perfect answer, but let's start talking about it. I heard both sides actually say that. I heard some people say 2016 was a better year in terms of points scored. I heard some people say 2017. So it doesn't really matter a ton. I gave pushback on either way. Can someone give me an argument for either one? I don't care which one. Maddie.
Aiden said 2016 because the point score is more than 2017.
2016 has more